It turns out we may have Mercury's orbit wrong. Not by much but by enough that a future mission can measure it, test Albert Einstein's landmark theory of general relativity, and further refine its mathematics. Mercury's importance is far greater than its small size might imply. It's one of the hallmark tests of Einstein's hugely important theory of general relativity, for example. But some new math shows that we may have been slightly miscalculating Mercury's orbit. So you don't accuse of me of overselling things here. I'll be frank, it's not a huge discrepancy. This is a tiny effect compared to the usually quoted relativistic correction. Konstantin Batygin, a Caltech planetary astrophysicist who was not involved in the paper, told me. But an interesting development nonetheless. Thanks to the gravitational pull of the other planets, Mercury precesses in its orbit, meaning it draws out a spirograph around the Sun. The closest point in its elliptical orbit moves slowly around the Sun in a circle. Newton's laws predict a 0.15 degree per century precession. But there seemed to be 0.01 degrees per century that went unaccounted for. When Albert Einstein debuted general relativity, an updated theory of gravity that describes really heavy and really fast things better than Newtonian physics, it mostly accounted for the remaining movement. Those general relativity fixes haven't been precisely worked out, since there's a lot of math there. Clifford Wall from the University of Florida calculated what he calls post-Newtonian cross terms from the other planets. These are the effects of the distant planets updated with a new precision of general relativity, as well as new effects caused by the planet's movement, according to the paper, published in Physical Review Letters. This would add an additional 0.00000062 degrees to Mercury's precession, per 100 years, according to a calculation by physics Catherine Wright. And scientists might be able to measure this as a test of general relativity. These effects are likely to be detectable by the Bepi-Colombo mission to place and track 2 orbiters around Mercury, scheduled for launch around 2018, Wills writes. General relativity tests are important if scientists hope to really understand their universe at its limits, or figure out how the theory connects to the seemingly discordant mathematics of quantum mechanics. So, our accepted measurement of Mercury's orbit might be off by a tiny bit. And, as curious humans, scientists won't be satisfied until they've nailed it. Physical Review Letters via Physics.